Well, hello everyone, and welcome back to Adrian's Digital Basement. Recently on the channel, I've worked on a number of terminals, and in the testing of those terminals, I wanted to see if the serial port was indeed working, and to make it interesting, I hooked them up to my modem emulator. And this is a Hayes 1200 baud modem where the guts have been replaced with an ESP32 that emulates the modem and has the LEDs on the front and the speaker and the sound and everything, but this actually connects over Wi-Fi, and I connect to a Docker container which is running Alpine Linux, where I can then run some old style utilities and VT100 tests and whatnot. I thought it would be really fun to see if I could get something running at home where instead of using the modem emulator, I could use actual modems. And I have a little stack of modems here that I've been collecting over the years. And I even have some modems that are still in their original wrapping that I've never used. And I always thought it'd be pretty fun to see if I could get something running at home that would allow me to use these old modems and potentially old style telephones like this. And instead of getting some boring ATAs or voice over IP analog telephone adapters that allow you to connect old style analog devices like these up to voice over IP PBX like Asterix, wouldn't it be more fun to see if I could get this stuff hooked up together using an actual analog telephone switch? Well, at least I think that's going to be more fun. So in this video, what I'm going to try to do is get such a switch working and then test out dialing from one modem to another, see if I can make some old phone calls just like I did back in the 80s and 90s. So without further ado, let's get right to it. Back in the old days, aka in the 90s and into the 2000s, before voice over IP was ubiquitous, it was very common for small offices and potentially even people with large houses to have their own phone switch. You did this because, say you had a large house or a business and you had, say, 30 phones. Well, it didn't make sense for you to have 30 telephone lines from your phone company. So the traditional way of getting all those phones online was you'd buy a little phone switch that you would connect to all the phones, and it would typically be an analog phone switch as opposed to the digital type that were used in large offices. And then to facilitate making phone calls and receiving phone calls, you would order, say, 3, 4, 5 phone lines, and those would actually connect up into your phone switch, and the programming in the phone switch would be able to route those inbound calls to various extensions. Maybe you'd have a little bit of a phone tree where you type in the extension you want, it would ring that phone, or it would do things like hunt groups, so an incoming line would just ring everyone's phone, and whoever picked it up was then connected through to that analog line that was connected to the phone company. This was all done in the analog domain, at least for the audio portion, and some of these systems had a digital signaling that would go to the telephones. You could buy special phones designed for that phone switch that would then give you a screen. It might show you who was calling, a bunch of line buttons so you could select which line you wanted to use or see other extensions in the office. But you didn't have to use those types of phones. You could just use a standard analog telephone or something like a modem and just connect it directly into the phone switch, and it used relays to switch between the extensions, and you could say dial 9 to get an outside line where it would connect you to the telephone company, and then you could make your outbound call. These types of systems fell by the wayside once the voice over IP really became ubiquitous because you already had a network to run your computer, so you just use that to do your telephone calls as well, and then you don't even have to get regular phone lines because you use SIP trunking and Asterix if you want, or any of the other turnkey voice over IP solutions. Believe it or not, back in the day, I used to run the entire telecom team of the large company that I worked for. So I'm very familiar with the way phone systems works. In our company, we had something like maybe 50 or 60 different phone systems all across the nation. And then we eventually consolidated that all into voice over IP with a single system that ran over a wide area network. And we got rid of all those disparate systems. So I really have a soft spot in my heart for these little small office phone switches. In fact, I can remember my first job when I was in high school, they had a Panasonic system. I think it was called a key system, and maybe 20 different phones and 5 or 6 different lines that would come in from the phone company. And it served that company really well. And it was mounted in the back of the office by the back door into the alleyway. And I remember you could hear the relays clicking away as people were making phone calls, or things were coming in and ringing, or it was connecting to the POTS lines. It was all pretty neat. And it had a voicemail system, if I recall, but it was external. It was hooked up through a couple extra ports on that, and it would route the calls that were missed when people were away from their desk into this voicemail system. And I think it would just route to regular answering machines, basically, with tapes in them. This was before the days of using a computer for your voicemail, like in the very late 80s and into the early 90s. So I was pretty intrigued when friend and supporter of the channel Vax11 messaged me and said that he picked up a small analog phone switch from VCF East. So if this thing works, which we don't know if it does or not, then I think this should facilitate me using all my modems and the few analog telephones that I have around the house to create a small little internal phone system for Adrian's digital basement. Of course, in this day and age, to hook this up to the regular phone system, I'd either need to order a POTS line, plain old telephone service from the phone company, or I could use an analog telephone adapter, as I mentioned in the intro, and hook that up to here and actually route calls in and out or to other people through asterisk PBX. I think I was getting ahead of myself. I think a really cool idea would be if I could just have one modem set to auto answer and I could use another modem at home and I could dial into it. And then, I don't know, just simulate the old sounds, truly simulate the old sounds of using modems over analog telephone lines. So I think we need to start by opening this package and powering this thing up and see if it even works, and then see if I can even figure out how to use it. It has been a very, very long time since I've done any work on phone switches, especially not voice over IP ones. All right, well, inside the package, here's that little phone switch. And we have a note. The note reads, Adrian, please find the enclosed Panasonic KX-T7020 PBX. I acquired this at VCF East 2025 and thought it might be of use to you. I tested it by connecting normal analog telephone lines, 2500 sets, between the first two lines, and I was able to dial between them by dialing 101 and 102 for the first and second port. As far as I can tell, it seemed to work okay. There's a serial port for configuration, but I didn't test that out. Hopefully you can make use of this with your modems to dial between modems. Yeah, Patrick VAX11 already knew what I was wanting to do with this thing. So that's why it's mentioned here. The PS1 model 2011 I donated a while back has a built-in 2400 baud modem. That would probably work perfectly with this. Thanks for all of your videos and helping me get through 2025. Hope to see you soon at the 20th VCF Midwest this year, September 13th to 14th. Yes, indeed. I already have my travel arrangements and hotel bookings for VCF in Chicago. In addition, just today, and this is not 100% final, but I just booked my travel to VCF in Dallas. So if you're in the Dallas-Fort Worth area or thinking of driving to that VCF, there's a good chance that I will be there. I'm going to post another update once I have everything finalized, so you can come out to say hi if I'm going to be there. But 100% for sure, VCF in Chicago, I will be at, just like last year. All right, here's that little phone switch. So the version I had in that job I was just talking about was probably 3 times the size of this, about the same width, but then it was much taller, mounted on the wall. Okay, and this has way more ports on it than I thought it was gonna have. I figured this thing might have something like 4 or 8 internal ports for analog phones, but this actually has 16. And these ports labeled CO 1 through 6 are the connections for CO or central office, and that would be the plain old telephone service that goes to your phone company. Of course, these are the ones I would connect the analog telephone adapters to if I wanted to pair this thing with voice over IP. Originally, this thing would have had some kind of a plastic cover that went over this area, and then all the wires would just route out the side. There'd be a big opening on the side, and you use this Velcro strip to hold those down. Looks like there's a couple 3.5mm inputs, or actually one's an input for external music. That would be music on hold, and an external for paging. Don't know the specifics of this particular system because we never used that feature at that job that I worked at. But usually the way this works is that would be hooked up to an amplifier, and then you'd have speakers throughout, say, your building, and you would dial a specific extension, and then when you talked into your phone, it would relay your voice to that speaker system. It's very much like if you're ever at the airport and they're doing boarding announcements. A lot of times they pick up a phone, they dial an extension, and they can talk into the phone, and then that is played through the entire gate area. And they can have a different extension to page, say, the entire airport if they're looking for a parent of a missing child. That functionality was totally available in phone systems just like this. Now on the left side of this, we have a power switch, on and off, and there is an IEC mains input and a grounding lug. And on the right side, the aforementioned RS-232 serial port, likely for programming, and the badge. Made in the UK. That's kind of cool. On the back, you can tell this thing was designed for wall mounting, which is pretty typical for the install of these types of phone switches. Now it does look like this front cover actually hinges down. There are hinges on the bottom edge. Let's pop out the screws, see what we see underneath it. Incidentally, I think there is space for one more card, so there's a gap right here. You could probably have another one of these line cards to bring it up to a total of 9 CO ports and an additional 8 internal lines. I assume that bottom card that has these ports for the paging and the music on hold is the CPU or processor card. All right, 2 screws out, and now you can get a good look at this analog beauty. This is the extra line card this has in it, with those 8 additional internal lines and the 3 additional CO lines. You have some additional protection for the lines that are going to the central office, most likely because you have to worry about surges and noise on those lines. But these are the internal ones. You have all these relays here that you hear the clickety clickety, and almost certainly all these analog components are going to be duplicated on the bottom board in addition to the processor or whatever else is on here. And you can see these extra connectors that are available here for plugging in additional cards. We have an EEPROM on the main board. It doesn't have a date code, at least nothing that I can tell, unless this is like 2008, but I don't think that's the case. This thing is probably older than that. I also noticed that this thing has a CR2032 for configuration storage, and that's almost certainly going to be dead. And I have a feeling that is actually, yep, it is actually soldered in place, so I'm going to have to remove that. Although, believe it or not, the battery has 3 volts in it. That is mind-blowing. That might be because this thing was just left running, powered up, well, for its entire useful life. And then when it was taken out of service, it was unplugged, and then the battery started taking over. But when it was plugged into the wall, the battery actually wasn't doing anything. I do have to wonder if the switch mode power supply, which is under this cover, is in good shape, but VAX11 said that this thing worked. You'll notice it says door phone / door opener. This was another expansion module that would clip onto the power supply. It wasn't inside the box. It actually clipped onto these clips, probably plugged into one of these connectors on the main board, and that would integrate a door intercom and door opener with your phone system. So what would happen is someone would push the button on the door phone and it would ring a particular extension. You would answer hello, or whatever the name of the business is, talk to that person. Maybe there was a push to talk button on the outside, but I don't think so. I think it was like a full duplex speakerphone. And if you were going to let them in, you push say pound or 9 or whatever the button was, and then there would be a relay inside the module here that would then allow energizing of the solenoid on the door that would unlatch it and allow someone to open the door or pull the door open. They could come in to see you. So unfortunately, that's not a module that's on here, but honestly, it's not something I would ever use. Although it'd be kind of funny to install something on the front of the house with a button and then say it would ring all your phones and you could say, who is it? No, go away, I don't want to talk to you. This stuff was really cool to have at home. And like I said, if you had a really big house and maybe you were wealthy, you might have a phone switch like this with these Panasonic phones all around. So you could facilitate talking to the person at your front door. But it was very common for small businesses to have something like this. And of course, nowadays you have a Ring camera or a Nest camera or whatever door camera with a 2-way intercom. It's all IP based and goes to your cell phone and all this stuff. But in the old days, these Panasonic key systems were really the way to go, and they were very turnkey solutions for enabling and facilitating all of this stuff in your small business. And it really brings back a lot of memories to have one of these here in the basement. Now, one thing I have to say about these Panasonic key systems is they were extremely reliable back in the day, and Panasonic used very high quality components for the manufacturing of this entire device, including Omron relays for all of the analog lines, and just generally good quality components. Notice we don't have any of those darn surface mount caps that are known to leak all over the place. All right, a couple more observations. We have a reset clear / normal and a clear switch available on the back board. Top lid has space for some optional modules, caller ID 1, caller ID 2, and OGM fax detection. Something would go there. It's my assumption that these clip into this location, probably affixed, and then there's ribbon cables that may go down and plug into these connectors on the PCB. I think what I want to do is try to take out this top board so we can look underneath it. And I bet you this just sort of pops up. I took out the 2 screws there. Oh, that came out very easily. Oh yes, just like I thought. A total replication of all the analog circuitry of this board is there. So the brains of the entire operation is this NEC part. All right, I took a photograph of the main IC so we could read it. D70433OD-12 V55. Makes me wonder if this is some variant of the old V20, V30, V40 line. I think they might have continued it. So this could be an X86 in there, which is everything integrated into it. While editing the video, I did a little bit of searching, and this is indeed the processor, the PD70433. And sure enough, software compatible with the V20 and V30. We have 16 meg address space, which basically implies this is a 286 clone, but it seems to be configured a little bit more like an 8-bit system in that it has only a single 4-channel DMA controller. They've also thrown in 2 serial ports and parallel port, analog to digital converter, 4 channels, and 8-bit sound output PWM. And it seems like at the time of this datasheet, this processor runs at 25 megahertz. I think we have the quad flat pack version of it. This chip is a lot more like the 8186 that Intel released. It's essentially throwing a bunch of extra peripherals internal to the chip, makes it perfect for embedded systems like this. But it also means this is not PC compatible because the locations and the IO port addresses for the various peripherals like the DMA controller is not the same memory location as it is on an IBM PC. So 4 channels of 8-bit analog to digital conversion. So that would be for recording audio. And then it looks like this is the PWM unit, which must output to a PWM pin that's somewhere on the chip. And it looks like the way the V55 implements the extra memory is with these extended segment registers, which are specific to the V55. And it looks like we have some other special features that are not on the original V20 and V30, which is 8088 and 8086 compatible, these 2 chips. Eagle-eyed among you might have noticed what looks like potentially a NiCad battery, but that is actually a supercap, 5.5 volts, 0.047 farads. Cool. Glad it was not a NiCad that could potentially leak and damage stuff. Another thing people may have noticed, we have a small neon lamp, which actually is replicated on the other board as well, which I'm assuming has something to do with some kind of surge suppression. Maybe that could shunt extra current into that and it would actually light up. Now looking around at the board, I don't see anything that really makes sense as a date code. A few chips over here and on the other board say 0112, that would indicate 2012, but that doesn't really make sense. And these ones say 0102, as in 2002. I could maybe believe this thing was from 2002, but I think even that is very unlikely. I'm thinking this thing is going to be from probably the late 90s. Putting this together is really easy. These have guide pins that guide you directly onto the contact, so there's really no issues. And then the screws are just these standoffs that would hold the additional line card. I thought first up, let's take a look online and see what we can see about this phone system. Looks like this company, KX-TD, still has some of these in stock. Price reduction on remaining inventory. Ooh, but we can see a photo of this particular unit with that extra cover that's missing from this one. Here's another website that has some more information on here. Initial configuration of 3 lines and 8 telephone ports, and expandable from 3 to 6 CO lines, which is what this has, and up to 24 extensions. Oh, all right. So I guess the additional line card doesn't give you any more CO lines, so you're still stuck with that same 6. But you can go from these 16 extensions this supports up to a total of 24. Caller ID compatibility, voice processor integration. Is that the voicemail system? I think it might be. Uses the KX-T7030 12-line speakerphone telephone, an analog digital model featuring a backlit LCD. It's designed for integration with this hybrid system. Also can use the Panasonic 7700 series phones. Okay, well I don't have any of those types of phones to do testing on, but maybe I will be able to get some at some point, although I kind of like using the old analog telephones and it's not like I need to have a screen and additional line buttons. And here's some of those cards. There's that caller ID card we saw. There's the 3x8 extension card, which is in here. And there's the additional 8-port expansion card that plugs on top of this card to give you those 8 additional extensions. Now, I remember the phones we had back in the day were not black like this. They were actually a light color phone, and they looked quite different than these. And I don't really know the intercompatibility between the other key system phones and these, although actually they looked a lot like this, except they were beige. Yeah, that's a very low-res picture. I am positive it was a phone very much like this, just a beige color, and each of these were various lines and other extensions you could configure in the phone switch. Now, the way these phones work is they actually use both pairs. Normally, a telephone connector has 4 wires, so 2 pairs of wires, and the middle 2 pins is the analog portion that would be used if you just plugged a normal analog telephone in or a modem or something like that. And it's the outside 2 pins that would carry the digital signaling and probably additional power, so the phone would stay lit up all the time while you're on hook. So that means when the handset is actually on the phone itself. Normally, a normal telephone is not powered unless you have an external power source. These would be powered by the phone switch with those extra 2 wires. And then all that digital signaling to light up the screen and configure all the buttons and then allow you to like go into a speakerphone mode. And if I recall, what you could even do is for paging, you could dial something on the phone switch, like an extension on one of the phones, and then all the phones connected to it when they were the smartphones like this would automatically go on hook on speakerphone, and you could talk to them and like blah, 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 and stuff like that. I don't know if this thing supports that, but phone systems like this always did support that, and you need to have the digital phones to do that stuff. With a normal analog phone connected up the system, it doesn't support any of those extra features like going on hook automatically for the paging. Now, what I need to look for is the manual, and I'm assuming by now all this stuff is just available and scanned. And here it is, the KX-T624. And these are the phones again that it supports, the proprietary telephones, some with displays, some without. I think the T7030 was the version that has the buttons that reminded me of my old job. The 8 extension expansion card, the one we already have in here, which is the 3+8, the OGM fax detection card, whatever that does. I think what that would do, actually, now I think about it, is if someone called into your business, and what fax machines would do is while they were waiting for a carrier, So they would listen for the carrier from the answering system. They would send an occasional beep, and that beep could be picked up by these detection cards, which would probably drop the regular phone tree that your call was in and route you to a fax machine. And then that fax machine would ring, or it would ring it from the phone switch. That fax machine would answer, give the carrier, and then the remote one that's calling in would hear the carrier. It would do a connection and then transmit. So caller ID card, we already saw that. And then there is actually a specific door phone that you would use as well. Let's see if we can find a picture of that. Oh yeah, that's it. It's just an extremely simple box that has an internal speaker and a microphone, and that was the button in the bottom right corner. No camera, nothing like that, but you'd push that, that would ring all the phones internally that were configured to ring. You could talk back to the person and they could push a button that would then open the door. And looking up the phone that I remember we had back at that job I had, and yep, it looks like there's a white version and a black version. So -W for the white version. And I'm sure plenty of sellers are still selling these for outrageous money, $250. Yeah, I bet you go to like any e-waste place and there is just gonna be tons of these phones just everywhere being shredded every day. People haven't used these types of phones in so long, and they've probably been stored in a box somewhere in a back closet, and then people clean out and they just throw that stuff all away. Wow, looking in here, this really reminds me of the DSS console. We had one of these at that job. So it's a bigger phone with potentially an expansion module, this 7040, and that would give you a visual indication of every single extension on the phone system, allowing someone who would say the front desk to be able to receive a call from an outside line, and that person asked for so-and-so. And this would allow that person to be able to look very quickly and see, oh, that person's on the phone, can take a message, or say, yep, 1 second, they transfer the call to that extension by pushing transfer and then the button for that extension, and they could hang up and it would go right through. Yep, bringing back memories. It has been a long time, but yeah, I remember we had one of these. I think it had the expansion module as well. And look at here's some specs on the thing. Control method, CPU 16-bit, control ROM 4 megabit, 1 megabit of RAM. You could tell they're a Japanese company with all this megabit stuff. That's funny. The switching is Space Division CMOS cross-point switch. I love it. I absolutely love it. It does support dial pulse, so pulse dialing as in rotary at 10 or 20 PPS, plus DTMF tone dialing and DTMF DP. Now, what I don't know is if you can use internal rotary phones to make calls to other extensions, or this is for supporting outbound calls to your central office. Yes, way back in the day, and I remember this when I was younger, our phone lines in our house did not have the optional touch-tone pay package. You had to pay extra for that. So if you had a phone that looked like normal keypads, there was usually a switch on the side that would allow it to actually emulate the old rotary dials phone. So you push like 9 and it goes click, 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 click. You hear it clicking as it's doing the pulse dialing. I suppose this particular phone switch can do that as well. That could allow you to save some money on your 6 external phone lines. And here's what I was talking about. So single line telephones use a single pair, the tip and ring, and then all of the proprietary phones with the digital signaling in addition to tip and ring, which is the main pair that the analog phone will use. It uses the additional H and L lines for that digital signaling and power. It looks like SMDR is station message detail recording. So this is not for programming, it's for a printer. It would just print out all your calls so you could keep track of what people were doing. Interesting. Now look at the max quantity list. You notice this thing says it supports 48 station terminals while it has only 24 extension jacks. That seems weird at first, but if we look back at the system highlights, this supports parallel telephone connections. So every jack in the system also supports parallel connection of a proprietary telephone and a single line device. They share the same extension number and are considered by the system to be one extension. So what that's saying is that when you're using one of the proprietary telephones, it must be communicating with the phone switch through the digital pins. If you call the same extension, both phones will ring, and obviously when you pick up the extension, you can't use the other phone for a separate call. It's really just one call per extension, but it's just interesting that they say it supports 48 phones, because technically it does. And I guess that means the power supply in this unit is powerful enough to run all those analog telephones, 24 of them, plus all these digital phones or proprietary phones at the same time. Here's the connection diagram, and I just love this. I love this. Look at this little radio here as your external music source. And then we have another amplifier for your paging. And then it looks like for your call logging to the RS-232 port, you can have a printer or a computer. Check out that computer. Yep, you know that's running MS-DOS. I see it supports up to 4 door phones and door openers. That's with that extra module, which we don't have. And you can have single line phones, data terminals, cordless phones, fax machines, and even the voice processing unit, that would be the external voicemail system. It says down here, it is recommended the extension on Jack 1 is a display proprietary telephone. Now, I think I might run into a little bit of a problem here. So this is what I was worried about when the RS-230 port was listed as for call logging. It looks like to program this system, you actually have to use one of the proprietary phones, and you set a switch on the phone to program, you dial some stuff, and then things appear on the screen. You can navigate through the menus. And I think this all happens through Jack 1 specifically. So I think that means that I'm kind of stuck with the programming on this, which hopefully it just works where each extension is like 0, 1 through, 16? And until I get one of those phones, I can't really explore any of the other features that this phone system has. And I can tell you, it's got a lot. This is a 400-page manual, and you'll see as I scroll through this, it's pretty much got it all. I mean, this might be a tiny phone system, but these little phone switches were extremely capable, and I think had a lot of the features that huge phone systems would have that were running entire big companies. And the reality is, I don't need to really program this system at all unless I want to connect up some external lines to it, either getting plain old telephone service from the phone company, which I'm not going to do, I can tell you that, or analog telephone adapters. Then I would need to add programming to this thing so you could dial out, receive calls, things like that. Outside line ringing pattern selection, single, double, or triple. These sounds were useful if you had different outside line groups, trunk groups, then people calling into like one phone number would have one ring pattern versus a different one, so you could tell right away. And then it looks like DISA, incoming dialing mode selection. I think this is the equivalent of DID or direct inward dialing. So it allows the phone company to send additional digits with an incoming call so that you could have a phone number associated directly to an extension versus having to go to a main extension or using a phone tree, which would require that external voicemail system. So someone could just dial directly to an extension with this DISA. The funny thing about all the stuff that's in here is that I bet you 95% of these features were never used with most installations of this system. But they loved adding all of the stuff into here just in case someone needed these features. And I suppose these are all software things. So implementing this is really just extra software. There's no hardware required for it, which I think is what's so cool about these types of hybrid systems, is the CPU enables all this cool stuff when the reality is the hardware that's in here is just really connecting phones together. And then we have a whole section on programming tables. And typically, if you had the manual, you write out and fill this all out, or whoever did your programming would. That way, in the future, if you ever need to refer to something or make a change, they could look in the back and see how the system was currently programmed and then make whatever necessary changes needed to happen. Yeah, configuring the hunt groups, station hunt groups, voicemail ports, DTMF receiver checks, hold mode selections, conference tones, paging access tones. So all sorts of stuff here. Pattern selections, call pickup tones, pulse redirection. Hold recall times, you put someone on hold, it will actually come back to them if you leave them forever. So you might set that to like 5 minutes, put them on hold, and if you forgot about it, then your phone would start ringing again. I mean, and just on and on and on. There's so much that this thing can do. And that is it. That's the end of the manual, and this thing is dated 1999. So I guess this thing is from, well, later than I thought. When I was working at that company in high school, the Panasonic phone switch we had, which looked very similar to this, and the phones looked very similar to this, I was working there in the early 90s. I think I got that job in 1991, and they already had that phone system. But one thing we can definitely tell here is that there is no way to program this through the serial port, and I cannot do any of the extra programming without one of those special phones. So let's just hope that at least the 16 lines that are on here, they all just work. So let's give that a try. So if you can believe it, I only have 2 analog telephones at home right now. Well, I have those modems, but I only have 2 phones. One of them is this, which is an actual phone, although it's not anything that's super good quality. Made in the USA with pride, it says here. It's got a metal base, but this is definitely, ROHS, so it's lead free. In fact, this is probably the date code 2013, so this is pretty late model phone. But I think it has an actual bell in it, so that'll be a good test. And I just have to find a cable to plug into the phone switch, which I think I have. And then the only other phone that I have is this phone, which is a wall mount phone, and it's red as well. And this one has a bit of an issue in that the jack was ripped off at some point. So I've since opened the phone up and I pulled the wires out. So I can cut a cable and connect this to a regular telephone patch cable to plug into the phone switch. Don't even know if either of these phones work, but I'm assuming they do. I mean, there's not much to go wrong with these. And I can tell this phone has a bell in it because if I just shake it left and right, it's ringing. So I think both of these are good like that. Let's do the same shake with this. This one as well has a bell inside, so that's pretty cool. I don't need no electronic bell sound. I want the old ring sound. So I went into my box of phone parts and I found this little box here, and I just screwed those 2 loose wires into it, and I think there was enough room inside the phone, and I just plugged a phone cable into it and it runs out the bottom. And I know there was a good reason for me to be hoarding all these phone parts all that time. And there we go. So that's the new connection, and well, that should be fine. Incidentally, if you used to work on phone things back in the day, you might remember these 3M Scotch lock connectors, which were excellent for connecting wires together. And these were sort of crimp connections. You'd feed the little wires into there and squeeze it down, and this has a little bit of a gel inside so that it actually provides some weather protection, and very typically used back in the old day when you were using this kind of wire, this patch cable, to connect various extensions together. If you needed to extend one of these, you didn't have enough of a length, you could use these little Scotch lock connectors. Yeah, I still have this giant spool of this interconnect cable, and this, definitely, it's only used for phone stuff. Okay, so this phone is connected to jack 1 on the phone switch. And let's connect this wall phone to jack number 2. Now, what I find really exciting about this phone switch versus modern voice over IP stuff is this is analog. This is entirely analog. Yeah, it's got digital stuff for those hybrid proprietary phones, but you don't have to use them other than for programming. You can just plug in the oldest analog phones and this will work. I think it said it uses 80 volts for ringing, which is plenty to ring the oldest phones. And how awesome is that? Okay, power is connected. Let's hit the power switch. I heard clicking. I'm assuming this takes a bit of time to boot up. So I guess let's see what happens. Do we have a dial tone? There you go. There was a dial tone there. It does sound a little odd. Let's see about this phone here. It's like, so this phone works, but there's a lot of noise on the line. Okay, well, I just dialed extension 1 and there it is. Hello? There's a lot of buzzing. I think the buzzing is coming from this phone. I think this phone may be bad. I think I found this in the trash at some point, and I guess they threw it away because it wasn't working properly. It's probably why those wires were ripped off the back. Let's see how this phone sounds. Yeah, so there's no buzzing. There it is, okay. So this is extension 102, and that's extension 101, I guess. Yep, there it is. So let's try that again. 102. Isn't that cool? Okay, so one thing I'm noticing is that the feedback tones for call progress sound weird with this phone system. So the dial tone doesn't sound exactly like I would expect it to sound. If I had a phone with a speakerphone, I could play it more loudly. It doesn't sound quite right for what should be a dial tone. But even beyond that, when I dial 102 for this extension, instead of hearing the ringback sound, which is a sound that, I don't know if you use the telephone system in North America, you're programmed to know what that sounds like. It's still the same sound if you call a mobile phone number in North America, that's the sound you're going to hear in your phone. This system is just playing what is the same sound as the dial tone as the phone is ringing. So the double ring we're getting out of this phone is exactly what you hear as a ringback feedback on the phone you're calling from. It just goes like burr, burr. So I'll try to demonstrate here. Well, no, I can't really. Oh, I'll dial extension that's not hooked up. 103. Okay, and I can hear it clicking. So there we go. That's the feedback sound. And the relays are clicking in there. I think what it's doing is connecting the ringing voltage to the handset on the remote end. It's cool to hear the sound of the ringing though, isn't it? Now, I suppose what I should do is just go through all the extensions on here and see if they all work properly. 103, 104, there we go, 105, uh-oh. So 105 is clicking, but it's not ringing the phone. So I guess that means either there's some damage on that port, the pins are perfect. Let's try 106. Yeah, 106 is working. 107, the noise that I was hearing through this wall phone, which I think is just bad, is happening on the other lines as well. Let me plug the good phone into one of the other ports, see if it's quiet. Yeah, it's quiet. So there's definitely an issue with this wall phone, and I really didn't have this hooked up to anything. It was just something that looked cool. It was down here in the basement. It's gonna go back to where it was, and I need to start procuring some other phones. 108, that works. 109 works. Yep, 110 is working. 111, good. 112. 113. This is scintillating content. Okay, I plugged into 114 and it gave me a fast busy. Yeah, it's fast busy. So it must be programmed to be something else, maybe voicemail or something. 115 just gives me a slow tone. Not sure what that means. And 116, same thing. So let's see if these work. Yeah, there's no dial tone on those. They just must be programmed to do something else. That was 116. Let's try 114. Oh, that's a dial tone. 101. 102, actually. Okay, so I can make a call from 14 to 2, but it gives me a fast busy the other way. That's probably a programming issue, really is. But number 15, I don't even have a dial tone, so that must be just configured for some other function. So the problem is 105. We have a dial tone. It can call to 102, but the other way around, 105? No, it's the relays are clicking. That means that line is programmed for something else. I wonder if that is programmed for 14. Jack 14 had a dial tone. Let's see, calling 105 now. Ah, okay. So line 5 on this phone system, for whatever reason, is programmed to actually call 14. So that means that line 5 is not bad. So maybe I plug the phone back into 5 and I call extension 114. No, it just gives me a fast busy. I'm just playing around with this system here. It seems that dialing 9 and 8 both allow more digits than just 3-digit extensions. Everything else, if you dial more than 3 digits, like 2, 3, 4, you get a fast busy. But if I dial 8 and any numbers or 9 any numbers, it just sort of gives you dead air. My assumption is it's trying to connect to those CO lines, the outgoing lines, and make an outbound call for you, which of course it can't because there are no lines hooked up. All right, so what I've done is we have 16 extensions. 15 and 16 don't give us a dial tone. Jack number 14 is actually routed to extension 105, and jack number 5, I don't know what that is. It gives you a dial tone, so I'm assuming it is some extension, but because we don't have any way to have caller ID with the special phones, I don't know what extension it actually is. So it means that the programming that's in this phone system now is good enough for me. And I think what I need to do is bust out a couple modems and a computer, and we need to try to dial between the modems because this should facilitate it. All right, a little time has passed, and I actually found a different phone, one that works properly. And this is an answering machine, as you can see, and I've discovered a few things about this phone system. One is it totally supports pulse dialing. So internally, you can pulse dial to this thing, which means I can use some rotary phones with this. And I have this crappy thing configured for pulse dialing. And if we dial 101, you can't hear it, but it's clicking. And there we go. It totally works. Now, this answering machine is the type with all digital greetings, no tapes, whatever. So if I hit greeting, I've recorded a greeting on here.
You've reached my answering machine, and you should leave a message after the tone because I'll never listen and never call you back. Bye.
And it has this synthesized voice otherwise if you don't record anything. So if I push set, we'll hear the menus.
Time 12:05 a.m. Sunday. Ring to answer 4. Message length 2 minutes. Security code 123.
How many people do you think had this thing set for security code 123? Probably everyone. Now I will use this phone to call the answering machine. And one of the issues is, of course, you're not supposed to call an answering machine right next to it. So there's a lot of feedback once it answers. So once it starts playing the greeting, I have to turn the volume down, and then I can record a message. And let's see, it's coming right up.
You've reached my answering machine.
Okay, so that's Hello, hello. This is a test of this junky answering machine, and it does work. And I guess if this had tapes, that would probably all be broken. But yeah, there we go. Okay, bye. Okay. One of the things about this is, I guess, the way this PBX works, it doesn't send the hang-up signal that this would normally detect, like a polarity reversal or whatever it is over the phone line. So you get that pulsing dial tone, but it seems to actually detect that that's an end call, because now if we hit all messages, we have a flashing 01 for one message.
Message 1.
Hello, hello. This is a test of this junky answering machine, and it does work. I guess if this had tapes, that would probably all be broken. But yeah, there we go. Okay, bye.
12:06
So
a.m. Sunday.
we got like,
End of messages. Low battery.
okay, yeah, got it. We got like 2 of those tones and then it cut off. Even though it recorded a lot more, it must know that that could be the end of call signal you might get from certain PBXs. I don't know. Now let's talk about the modems that I'd like to test. These 4 modems I've just had kicking around the house for a long time. I've never had a way to test them because I didn't have any kind of telephone lines to plug them into, so now I do. This is a 2400 bits per second modem, a Zoom modem, and I had this exact modem way back in the day. Now this is an actual Hayes smart modem with 300 baud. I think pretty much the AT command set that you probably are familiar with, it was introduced with this specific modem. So that's pretty cool. I got that off eBay ages ago. And I have these 2 14.4K modems, a Supre modem and a Practical Peripherals 14.4 kilobits per second. If you're familiar with modems from back in the day, you'll know the top speed of modems was 57.6 kilobits per second. That's over regular analog lines. Unfortunately, none of these modems are that fast, which would be fun to be able to test the maximum throughput through this phone system between 2 modems. Well, the only one I have that can actually go 56K is this one. This is a Courier V Everything modem, and I had one of these back in the day. So let's open up the Courier modem, which has never been opened. This thing is brand new in box. And let's hope that this modem inside here is still working. All right, well, there's the unboxing of a Courier modem. Never used, USRobotics, very nice. This brings back all the good feels of when I bought that modem and spent a bunch of money on it. Came with a 25-pin to 9-pin serial cable. We do have a phone cable, and we will have the power supply. Oh, a couple other little goodies in here. Register your product today. Take a moment to register. Thanks for choosing USRobotics. Sure. Gotta use a stamp though. Schaumburg, Illinois. Yep, right near where VCF Midwest is held every year. And what else is in here? A little ferrite bead thing to put on the cable, probably on the phone cable. Interference suppression, and a CD-ROM. This was obviously a later modem. I'm quite sure the version I bought didn't have a CD, but actually came with papers and books and stuff like that. But this is a later one, obviously. Okay, and there is the Courier modem. Not the most stylish thing in the world, but it was such a high quality modem. It was what everyone wanted to have. So there's a volume slider on the bottom. On the back, there is the power input, the 2 phone jacks, and the RS-232, along with a power switch. And notice switch 5 allows us to set the modem to auto answer on ring. That's very handy for us when we're going to be trying to call this modem from one of the slower modems to get our, well, I don't have a BBS, but at least we can get a call going through the PBX. Okay, so seems like we have a switch mode power supply because, well, there's a bunch of adapters. I thought this modem ran on AC, but clearly not. A lot of modems and telephony devices, including that answering machine we just looked at, does run on AC, but this thing runs on 15 volts DC. I gotta say, this has that smell of electronics, and you know, it's been sitting in a box for probably, what, 20 plus years. It still smells good though. It reminds me of when I bought this thing after, like I said, saving up a whole bunch of money. I don't really remember how much these cost back in the day, but they were very expensive. But I was serious about modeming back then and BBSing, and that's why I bought it. Okay, first things first, let's check that the power supply is working. It is. Okay, looks good. It's making a little bit of a squealy noise out of the actual PSU, but that's probably because it's not loaded up right now. Now, I vaguely remember that my Courier modem had a power switch that was actually a toggle. Like, it was black plastic, but it had an on-off position. So this one, I don't know, this might be a bit later of a model. Let's see if it works. Okay, There we go. We heard some relay clicks inside. This does have a peel on it, and I'm going to peel it because I really don't like leaving these on. Very nice, very nice. Well, let me set switch 5 to auto answer on ring. So let's move to the up position. And I power cycle the modem, and the auto answer light is now on. That means the modem will answer automatically if I call extension 102 or not. But I think it's not doing it because you can see the lights are on. But what's not set right now is DTR, data terminal ready. And typically that will become asserted when I plug this into a computer. So it will not answer the phone if your computer is, say, offline. So this cable is connected to my lab PC. Okay, I fired up PuTTY, and now the DTR light is on along with RTS, which is ready to send, clear to send, CTS, MR modem ready, and then the auto answer light. So if we type AT, we can see if we're getting a response from the modem. We are indeed. I think this command will show us, oh, I can't remember my commands anymore. I think this has to do with like firmware or something like that. I don't remember what this stuff does anymore. USRobotics Courier V Everything EXT for the external version. Now what I can do is I can dial this phone with ATDT101, which is the extension. Okay, that works. Now if I call the modem, 102, ring, whoa. There it is. Speaker in the modem is horrible. This is clearly a much later modem because, yeah, the speaker in this modem is very hard to hear and quiet. It was super loud in the version that I had back in the day. Yeah, so this is clearly a late model modem. All right, which one should we test first? Well, I'll start with the practical peripherals modem. I have this Atari 800 power supply. It supplies 9 volts AC, which is what these modems all seem to use. Well, that seems to work. We have modem ready, terminal ready. I have this phone cable plugged into extension 103. See, line and phone. We're gonna plug this into line. Okay, we're at 19.2. Let's go to 38,400. And there it is. ATI3 is a PM14400FXMT, revision 1.53, Practical Peripherals Incorporated, 1994. I had a Practical Peripherals 900 bits per second modem. That was the one I had before the Courier V Everything. And boy, did I spend a lot of money on that modem too. I think it was like $400 around 1991 or 1990. I loved it though. It was so fast compared to the old Zoom 2400 baud that I showed earlier. So this is like the later iteration of it. Okay, so the Courier modem is now plugged onto COM3 on my computer. Yes, I have a bunch of serial ports on my modern bench PC. We will run this at 115/200 as fast as we can go. Let's see if we are talking to the modem. We are indeed. So ATI4 seems to show all the configuration settings, which we may have to fiddle with a little bit just to get this, well, these two modems connecting properly, especially from the 300 baud modem that I have. I want to see if that works. Okay, so the Courier is in auto answer mode. So theoretically, if I call it now, ATDT 102, the speaker is so bad on both modems. Oh, it's loud, it's screechy with these bad speakers. So there it is. The Courier tells us exactly how it connected. 14.4 ARQ V32 and V42 BIS. V42 BIS is a type of compression that actually compresses your data stream. So even though we're connected at an actual physical transport rate of 14.4 kilobits per second, you actually can go faster than that using the compression, the V42 BIS. And that's why it's really good to connect to these modems with a higher bits per second, like say I'm at 38.4 on this modem, and on the Courier, I'm at 115 kilobits per second, because transferring data, you can be going faster. So now, hello, I mean, this is connected. And hello there. Yeah, so this PBX is facilitating this 14.4 kilobits per second connection right now. Now there are a bunch of settings in the modems, like in the practical peripherals, that we could tell it to make an outbound call at a slower rate. Of course, I can't go faster than 14.4. It's the fastest that this modem supports. While the Courier supports originating calls, which means like it's the dialing out call of up to 56.7 kilobits per second. I'm quite sure that you cannot attain that speed both directions over PBX when you have modem to modem communication, physical analog modem to modem. I'm quite sure the modem on the far side actually needs to be connected to a digital line. So for instance, you might have a special modem concentrator with a T1 and it would have 24 modems inside. And those could support that 56.7 kilobits per second, at least for sending from the far side, the answering side, to your modem. From my recollection, and this is totally off the top of my head, this had to do with the conversion that was happening between the analog signal going to your house, and then it would go into a digital domain at the phone company side, and then be transmitted to the modem digitally, all the way through to the modem on the far side. That thing is, that conversion process at the phone company was really designed for voice calls and not data signals, which is why you couldn't go quite as fast. I think 38.4 was the fastest upload speed you could go from analog to digital. And I suppose if you had two modems, then maybe that would be analog to analog, and you would also get 38.4 both directions. All right, so let's use this web page. Let's paste that in here. I mean, there it goes. And you can see it's going pretty quick as well. Let's do the same here. It's transferring the data fast. Now, when you use a proper protocol to transfer data, like Z modem or Kermit, it will actually tell you how fast things are going. And that's how you did it back in the day. And you needed to do that because in case, say, someone picked up a phone while you're in the middle of transferring, you need to be able to resume. And Z modem had the ability to resume transfers. Now, one thing I think a lot of people didn't really realize is that a lot of these modems had a second port for an upstream telephone, and it would actually cut off your phone. So if you plugged your phone into there, and you, say, picked up the phone while the call was going, you wouldn't hear anything at all. So you wouldn't risk screwing up your modem connection. So I'm gonna grab the cable out of the PBX. Let's see if this modem actually works that way. Okay, no. So that is the sound of it having a problem right now. And it was like flashing the carrier detect light there, and it's basically retraining the signal. So it's trying to keep the modem connection alive. And yeah, basically I tried pasting data there while it was doing that, and you could see that there's a bunch of garbage, and then look, no carrier. So it couldn't do the retrain process, which is basically trying to reestablish a connection between the modems because I had picked up the phone. So this practical peripherals modem definitely doesn't cut off the extension that is connected to that modem port. But I have to tell you that there are modems that do that. And the reason why that was really helpful, because back in the day, I would be, say, transferring files to a friend, and we would leave the phone off hook. So it would just be sitting on the desk. And when we were done with the modem session, and we were, say, typing to each other through the modem, we'd say, okay, let's switch back to voice. One of us would just hang up the call. So +++, ATH for hang up, and then you would just drop back to the voice call because you both had the phone off the hook. It would then just suddenly switch to this, and you could have that conversation, and you could go back and forth easily enough. Like you could be on the phone and be like, hey, I need to transfer some files to you. Oh, cool, okay. Well, one of us would type ATA, and the other would type ATO for originate, and that would reestablish the modem connection. Okay, well, what's cool though is that this modem is working well. I mean, it works, I think, as well as it would have worked back when it was new. Okay, next up is a Supra fax modem, which is basically the same thing as the one we were just trying. Boy, that doesn't really go in there very well. I don't have any of the original power supplies that were from any of these modems from back in the day. Power on, modem is on. These are all the config registers of the modem, but it is obviously communicating version 1.411. What we can do is dial the other modem, which I think is 102. Okay, interesting, the sound on the Supra modem is turned all the way down. So the sound you're hearing right now is coming from the courier modem. Okay, protocol LAP-M. And on the courier side, it's exactly the same as it was with the other modem. Okay. Oh, something's wrong. Okay, so I'm typing on the courier side, and there's nothing coming from the Supra modem at all. Even though we're obviously communicating with the Supra modem because I was able to, communicate with it, dial and everything. But right now, if I'm over here and I'm sending, we should be seeing text there, and I'm not. Now, the other way around does work because I can hit enter and I'm typing or pasting the text. There it is, it's sending. Okay, so we'll do +++. Okay, so that broke out. So it's still connected. The two modems are still connected. but for whatever reason, it's not working. So ATO brings us back to the connection, and let's just see if we are able to, no. So it's still not sending anything at all. Very interesting. So I can do plus, 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 the right way, there it is, and we get ATH, that hangs up. I think F is like factory default, and AT and W writes those into the modem. So let's try calling the other modem again. Oh, yeah, there's volume out of the speaker that's coming out of the Supra now. So whatever it was configured to have the speaker turned off, now I can hear them both connecting, and the speaker sounds a lot better than it does on the practical peripherals modem. This is actually connected? Oh, there, it just took a second to like negotiate or whatever it did. If I send on the Supra side, we just get that. It's like we have a baud rate mismatch right now. That's what I think is happening. I'm not really having any good luck finding the manual for the Supra modem. There's a lot of people selling them, including the manual itself. Well, like here's a modem plus a manuals. And this is actually the sticker that's on the bottom of the modem. And I did AT and F, reset to factory default settings. And then we have a couple other ones we can do is auto reliable Macintosh or auto reliable all other. So why don't we try AT and F2? Okay, AT and F2. Okay. And then we'll write that into the NVRAM, and let's try calling the other modem again. Okay, there goes the carrier and the negotiation. Okay, that's better. It didn't change the baud rate on my end, on the Supra side. And there we go, the connect string looks normal, and if I type, it's working now. Let's move this down here so you can see it. And let's move that down there. Okay, cool, we are operational. AT and F2, that was the key. Let's do a few clicks. Click, 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 click. There we go, full duplex communication between the two modems. All right, I have the telephone connected to the upstream port. This is the red telephone. Let's pick it up. It's making noise. Let's hang up again, let's see if this thing can retrain and work a little bit better than it was with the other modem where it would just sort of hang up. It's trying, but we're not getting any kind of communication between the modems right now. Oh, it came back. It freaking came back on both ends too. Nice. So there you go, like, oh, there, it got upset and hung up. So just like before, it retrained, it worked for a little bit, and then it's like, nah, I'm done. I just gave up. Okay, so far, both the Supra and the practical peripherals does not switch off the telephone jack. Pretty lame. But let's take the phone cable and plug it into the courier modem. Let's see if it does that switching. I didn't really expect this video to be a modem video because I just really wanted to test this PBX to connect the modems together, and it's clearly working. But I think it's just kind of fun to try out this stuff that I've kind of forgotten everything about, like when it comes to the connection with the phone into the back of the modem. Okay, so with the phone plugged in, let's call the other modem. The phone should ring. That's what we'd expect. And here comes the connection between the two modems. Okay, now if I pick up the phone, nothing. There's no sound here. So the courier actually has a relay inside which disconnects the phone. And I guess cheaper modems, they just did away with that because they wanted to save a little bit of cash or whatever. Now if I do plus, 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 okay, and I'm gonna pick up the phone, ATH, there it is. So if the modem on the other end had the same relays thing, then like I said, you could leave the phones off hook on both modems, and when you hung up, you could continue the conversation with the call you already had in progress. Okay, so I want to try another experiment. I'm going to call the Supre modem from the phone, plugged into the courier. Okay, ring. And I'm going to listen here, and I'm going to type ATA so I can wait for a carrier. Okay, there it is. I'm going to push the button on the front of the courier. There we go, it actually connected, it worked. So the courier modem has a button that says voice/data on the front. So what you can do is I called the other modem, it answered, I heard the carrier through the phone, I pushed a button on the front of the courier modem, and then the courier disconnected the phone and then established the connection between the two modems. And that's what we have right now. And if I pick up the phone and I push this voice data button right now, then it hangs up, but I now hear the PBX. Okay, let's try the next modem, this 2400 bits per second Zoom modem. And this also has 2 phone jacks. I do not know if it has the relay though. And let's see if the Zoom modem works. Does. That's normal. Boy, I used this modem for a long time. And it wasn't actually this modem that I had. This is just another one of the same exact model that I had. The modem that I had, the Zoom modem I bought at Egghead Software in Los Angeles on Beverly Boulevard. And I had saved a whole bunch of allowance or whatever it was, and whatever the modem cost, I don't really remember. I went in there and I bought it, and it was an upgrade from a 1200 baud modem that I had. My progression of modems was 300 baud, and that was not an auto dial modem. You had to flip a switch on it to connect to the other end. That was with an Apple II Plus that we had as a family computer. Then I got my own 1200 baud auto dial modem. It was a Hayes clone. So it looked like a Hayes modem, but it was a fake Hayes, 1200 bits per second. And then I went and bought the Zoom modem, 2400 baud. And then I went and bought 1900 baud practical peripherals. And then the next upgrade was to the USRobotics courier modem. All right, so this window here is the modem, but I think what's going on is, yes, it's not working, and that is because this is a 2400 baud modem, and it does not have any compression internal to it. So I'll have to change the baud rate, I think 2400 bits per second, and that is all this modem can support. AT and V shows us the active profile at least. The extra spacing is just a terminal setting I have. So this modem does have NVRAM, and that's what the stored profile 0 and 1 is. I don't know what profile is stored in here. I've never turned this modem on. I don't know where I even got this thing. But let's dial the other modem, 102. Oh, yeah, that sound really reminds me of how things were on this modem. So here's the thing. The far end, there we go. Okay, so I was gonna say, the courier modem started with a carrier that had like a clicking in it, D. That is for the higher speed communication methods, like V32, I think, uses that with the dots in it. 2400 baud, on the other hand, the carrier sound is just a solid tone. So the Zoom modem waited to hear the carrier that it was expecting, just the solid tone, and then you heard that much quicker connection strategy between these two modems. And you can see here on the courier side, it just says 2400/none. There's no compression, no error correction, none of that. This is just purely 2400 bits per second connection between the two. It's really when 900 bits per second came out that all this compression and extra protocols came into play that made modems more reliable over long distance calls and stuff. Obviously with this PBX, there's no noise in the PBX. It's a nice quiet signal. Let's see if I pick up the phone, what happens? I bet you it's gonna just put a bunch of garbage on the screen, well, at least for the far end, the courier side. Here we go. Yep, so I hear the noise and I think we're still, yeah, okay, we're still actually connected. Let's copy and paste, and you can see how much slower 2400 bits per second is compared to how it was before. So let me pick up the phone while it's pasting. I mean, it's still working. That's the modem sound, and it has not caused an issue. This is much slower of a connection. It is much less prone to errors from, say, noise on the line. It's like a much more resilient connection. And that's actually one of the things that whole retraining process does when you're connected between two modems at higher speed, is theoretically it can actually try, if there's noise on the line, to like downgrade the connection speed to a lower speed, a more robust and reliable one from those high speeds. Okay, let's try this again. Now the whole buffer. Hello, hello, hello. I'm gonna push buttons on the phone. Huh. That's still connected. It is absolutely still connected. I think we have a flow control issue because it looks like we're missing some of the text. So let's just try this again. I'm gonna push buttons on the phone. I mean, it's still working. It's so resilient. How about the other way? Hello, hello. Yeah, 2400 bits per second. Very, very, very reliable. But what's cool is that this little modem does work. That is awesome. These things are reliable. No one's using them, but they're still reliable. Okay, that means we have our final modem to try, and it's the 300 baud modem from Hayes, the original smart modem. Smart modem 300. So it says on the back this uses 13.5 volts AC, and this little power supply is only 9. So I have this 12 volt AC power supply, which I think should be good enough. All right, let's see if this modem powers up. Again, I don't even remember where I got this. It might have been from eBay. Nice, it powers up. I was buying these smart modems off eBay just thinking it would be cool to have one. Oh, this doesn't even have a jack for the phone. So this definitely doesn't have a pass-through, so we can't test that relay thing. Yeah, I was buying these modems off eBay just so I could have them because I had these types of modems when I was a kid, and I just thought it'd be kind of cool to have these, so I just went and that's where I got all these modems. And it was years ago, and like I said, never even tested them because I had no way to actually use them, unlike now. Okay, well, obviously a 300 baud modem, it's not going to work at 2400. There's no compression or anything like that. And while we're at it, let's check on the serial settings for the other modem. Oh yeah, X on, X off, that's the problem. It should be RTS, CTS. Okay, now the flow control will work both ways. AT. Okay, wait a second, so this modem might not be working. If I turn the modem off and I type on the keyboard, I don't even get any characters echoed. The echo is coming from the modem. Oh, I think it requires uppercase. Yes, it does. Uppercase only. I completely forgot about that. All right, let's try that again. There it is. Good, solid speaker, has a volume knob on the back. Okay, so it's gonna have to wait all the way for the 300 bits per second negotiation to happen. It worked, it freaking worked. It just says connect. It's not even like there's no speed or anything. It's working. Okay, I don't know why it's so laggy. From the haze to the courier, as soon as I push the letter, it appears on the other end, but I guess it just seems really laggy the other way. I wonder why. It's kind of odd what's happening here, because if I lift up the modem so we can see the lights on it, as I type, as soon as I type, the light is blinking. I think that's out of focus a little bit. But oddly enough, it's like it has this weird buffer. So I'm going to type OK, OK, OK. And the lights flashed on the modem in real time, coinciding with my typing, but it didn't appear on the terminal there till later. Yeah, it has to be putty. It doesn't make sense. Because there's no way that the slow modem could send a burst of text that quickly from the modem over the serial port to putty. So yeah, it's got to be something that putty's doing. Let's try pasting some text here. Let's see this glorious 300 bits per second transfer rate. There it goes. It's so slow. It is so hilariously slow. Now the light on the modem is just solid on. It's transferring as quickly as possible. Let's try it the other direction. So I'm going to paste from the haze over to the courier. So I'll click here and there it goes. That's the actual speed of 300 baud right there. I think it is. Or is this 110? Maybe we're connected at 110 right now. I don't know, actually. We could be connected at 110. That seems really slow. The red window is the haze modem, and this black window is now the Zoom 2400 baud modem. So let's call the other modem the Zoom modem. Should see a ring here. And I don't have auto answer enabled, so we type ATA to answer. Okay. Okay. Sounded weird, but I haven't heard a 300 baud connection in forever. Oh no. I think what happened is the Zoom modem switched baud rates down to 300. It doesn't have the capability of buffering the baud rate. The baud rate of the serial port's always linked to the connection speed. So I need to change this, and yep, now we're good. And this weird buffering thing, yeah, is a putty problem, obviously, because they're both doing it now. Interesting. And you can see how slow 300 baud is. Very slow, very, very, very slow. All right, that is going to be it for this video. I just really wanted to show that with an old analog phone switch like this, you can use your old modems again. It has been so long since I've played with modems. That's why I kind of went off on this tangent, and all those things I was showing, like picking up the phone, and it's all stuff that like everyone who used modems back in the day experienced. And it's really awesome that all these modems that I have all work. I haven't tested all of them because I still have a couple more that are still in their original box, but it's pretty cool to see they all work. And it's neat to see that this PBX can facilitate calls up to 14.4 at least. What is cool though is if you want to feel the warm and fuzzies with using a modem like I was just doing here, you can pick up these phone switches. I think they're pretty inexpensive. I'm not sure how much Patrick paid for this, but it wasn't a lot at the VCF consignment table. And if you check eBay or look at e-waste places and stuff like that, they might have stuff like this that kind of comes in periodically. You can get it super cheap and then you can play around with your old modems again. I think what I want to try to do is get to the point where I have maybe a Docker container hook up with a serial port, like a USB to serial adapter, to a modem, and then I can run a BBS or something like a Unix system or whatnot. And then what I can do is keep one of these phone wires on the bench, and just anytime I want to test a modem or test an old terminal, just plug in one of these real modems into it, and then just dial in to the Docker container to that Unix system. It's kind of what I'm doing now with the modem emulator over Telnet, but this would be actually doing it over an actual analog telephone line. I'm thinking about this. I've had this red phone for a while now. It would be pretty fun to put some analog phones around the house and just call people when they're when they're in the house. Or I suppose with an ATA hooked up to Asterisk, I could hook that up to alerting. So if like a server alert was happening at home or whatever, it could phone me and then use voice over IP and text to speech to actually say something. Yeah, there's a lot of neat stuff I can do. Unfortunately, I used to have punch down blocks, the punch down tools, all of that stuff. I don't know where any of that stuff is anymore. I haven't looked at that stuff in ages. So it means if I was going to try to start running some lines to various places in the house, that I would need to get those tools first. And I mean, it seems like a silly waste of money to get that stuff too, doesn't it? But it's been super fun playing around with this, both the analog telephone nature of it, the clicky sounds of this old phone switch, the modems, all this stuff. What an absolute blast. So I hope you enjoyed this video. If you did, thumbs up, all the usual YouTube junk. Thanks to my patrons and supporters that make it possible to do this full time, all the usual YouTube junk. And I guess that's gonna be that. So let me know down in the comment section what you think I should do next with this whole setup. And if you have recommendations for like a way to run a BBS through Docker and stuff, if you've done that, let me know as well. And yeah, I mean, that's gonna be that. So stay healthy, stay safe. I'll see you next time. Bye.